Good morning, afternoon, everyone, or even evening for some of you. Thanks for staying with us on the LRVS. So we have for this session, I'm very pleased to introduce Ruediger Krethe, who is the CEO of OilDoc. And in this presentation, he will discuss sustainability and lubrication. You can find more information about him and connect in the speaker profiles. You also have Ruediger's code now shown on the screen on this side. If not, yes, correct. And with no further ado, I will launch his video, and after that, I'll find you again for a short discussion with Ruediger. Enjoy.
Hello, I'm Ruediger Krethe from OilDoc. Thank you for joining my presentation about sustainability, lubricants and lubrication. Sustainability, what's that? More or less, this should be the fundamental principle of our life. More or less to make our existence safe for a long time. Or with other words, how we work with our environment. What footprint we put to the planet we are living on. And this in the long term. And an holistic approach brings it together. The environment, the social life, we are human beings, and the economics. Very often people think sustainability it's a costly thing. But I'm not sure this is right. Sometimes, you know, today you will hear the word sustainability very often from politicians and on the main floors of the top management of bigger companies. And sometimes, if you go in detail, you'll see there are some prestige projects like a light tower, good visible, focusing only single aspects, but at the end of the day, the world is not changing. Nice to see what they do, but at the end, the world will not change too much. What about sustainability and lubrication? Several studies bring it up. We lose per year billions of dollars due to poor lubrication practice. Energy consumption is one thing, and the next are materials we are working with. How long we use them, and the oil, of course, at the end. But how to do it better? Minimizing frictional losses by better lubrications, better materials, better machinery design. And the materials, of course, if they have a higher wear resistance, we can use them longer. And today we have one overall measure for that, the CO2 footprint. And if you go to the politics, I'm not wondering that their main strategy is we have to have new machinery. They have to be designed that they are more efficient. We use materials. They have maybe a higher wear resistance. We have a better design. We have better lubricants. And it's good and right and crucial in doing that. But is that really all what we should do? Let's put a realistic timeline on that. The average life of a passenger car in the European Union, we talk about approximately 10 years. If you go to large industrial equipment like turbines, like turbo compressors or other bigger machinery, then we talk about 50 to 60 years. And even if you put some updates from time to time on that, they are not new. And smaller components, there you can have a lifetime like the passenger car, sometimes even they are much longer. What's the problem? Michael Duncan, the president of the Society of Tribologists and Lubricating Engineers, bring it to the point. Even if we begin to replace internal combustion engine vehicles today with battery electrical vehicles, it will take 20 to 50 years before a significant impact on global warming can be achieved. 20 to 50 years. What we can do in the meantime, how we can improve sustainability today. We can modernize our machinery. We can use better lubricants. We have better lubrication practice we can do. And especially tailor-made service concept can do that. More sustainable lubricants. Of course, we talk about lubricants based on renewable sources, bio-lubricants. And not only in total loss systems, but we talk also about longer oil drain intervals when we use more saturated base oils, better additives, the lower internal friction due to a high viscosity index. We can work with less internal friction of the lubricant. And of course, by better additives when we use them mainly for lubrication. And of course, we should at the end of the day have in our mind, if we use a different chemistry, we should think about material compatibility, about mixability and so on. But we can handle that. We know that for years. Biolubricants and hydraulic fluids. Customer, if you ask them very often, they say, hey, biofluids, they are costly. And what about the performance and the material compatibility? I don't know. I have doubts about that. But go to the reality. There are also big advantages. They have a higher viscosity index and it is shear stable. If you go to esters, for example. We have a higher oxidation stability, and ester-based lubricants, due to their high polarity, they have a better lubrication capability than the base stock of a mineral oil or polyalpha olefin. The material compatibility is different, but we know those lubricants for more than 20 years, and we can handle that. And the hydrolytic stability you can improve. Here you need a better service concept like bypass filtration. Get the water out. Therefore, don't compare them only by price tag. Put all things together and at the end of the day you will see it's not that costly you were thinking in the beginning of that. Some examples later on. What about energy efficiency of hydraulic fluids? Using a better hydraulic fluid, you can increase the energy efficiency up to 5% and more. The fluid-related efficiency of a hydraulic fluid depends mainly on viscosity, viscosity index, and density. The density is very often not in focus. And now you have different solutions. Mineral oil and viscosity index improver, a base oil of group 3 or 4, that means hydrocracked or polyalpha olefin. You will see the viscosity is high, the density is low, that's good. And Some of the esters, they have even a high viscosity index, but the density is higher. And therefore, it depends on application, which is the best solution in energy efficiency and the costs if you put it together. And if you want to get out, it's really energy efficient or not, the easiest way to get an indication is to measure the fluid temperature and operation and compare that. The real consumption to measure is very complicated. But sustainability is more than efficiency. And if we talk about the costs, what about the shear stability? We can use them longer due to the maintaining the right viscosity, the oxidative, thermal and hydrolytic stability. That means a longer oil drain interval, material compatibility, and so on. And if we again put the different service needs of these different fluids together, we can get it. Therefore, the best solution depends on machinery design and the operational factors we have. Gearboxes and power losses. There you have two classes. The first, load dependent. The second, load independent, auxiliary. What's behind? You can have the same type of gearbox. You operate them different, you have different influence factors. That means if the gearbox is running at nominal load and speed, the losses are dominated by load-dependent losses. That means lubrication, additives, it's a big influence there. But the load-independent losses, the viscosity comes much more up than the additives you have in. Some examples. It's cement plant. The idea, we replace a 1,000 liter hydraulic system of a clinker cooler drive by a polyalpha-olefin. It was operated with a mineral oil. The first reaction of some colleagues, hey, you are stupid, that's that costly. Why in the world you want to do that? But that's not the end. They said, hey, and we will do the same thing in the main drive of a cement mill. Kick the mineral out and we replace it by a fully synthetic polyalpha-olefin, 3,000 liter. And then they measured really the energy consumption. And they realized the following. They saved per year 50,000 bucks per year. And that means at the end, after 1.5 years approximately, it was break even. And then they started to earn money with that. The return of investment less than 2 years. And now, because of the use of synthetic oil, of course, even just now, per year they save a lot of money. Peter Jones, the father of tribology, brings it to the point. By the way, not yesterday. In the 60s of the last century, he got out lubrication best practice saves money. Billions. Here you see 20% cost reduction for maintenance and refurbishment, for lubricant procurement, less work for unnecessary repairs, and so on. And these are the billions we lose every year by poor practice. But lubrication practice has to be done. It's not enough to write a nice manual. The difference make people. People with an eye for the right detail and without losing the view to the reality. What about rolling bearings and lubrication? Failures and lifetime. You will find many those publications, those graphs here. If you sum it up, approximately 80% of the failures of these bearings are related to lubrication and contamination. And these are things we have a big impact with our daily work. 80%. Hydraulic pump failures. More or less the same story. If you put it together, by design, 2%. It's nothing more or less. Manufacturing 6, 3 times higher. Installation 12, even 2 times higher. But now the end of the story. Maintenance and operation more than 80%. 80%. Do you know Mr. Barreto? Bad news about lubrication and failures. Failures are caused by lubrication and maintenance, as you have seen here, in rolling bearings, hydraulic pumps by 80%. But in my opinion, these are not bad news. These are good opportunities to bring our sustainability and our economics to a better level. The good news are, following easy rules, we can avoid the majority of our premature failures and of lubricated components. Mr. Barreto means following easy rules, 80% you can get out. Lubrication excellence, 7 rights. The right lubricant, the right place, amount, time, method, condition. You know that from many maybe trainings and seminars. I will not go in detail here. But the main difference, again, are people. People not only knowing that, but doing that. And of course, here the management and the people in daily work have to collaborate to bring it to a better level. Oil and machine condition monitoring concept. What's behind? The oil can fail, the machine can fail. And of course, if the oil is in bad condition, even the machine will not become a better condition, and vice versa. And for both of them, there are root causes for failures. Knowing that, better practice. But of course, we can also monitor our oil and our machinery to get out what is the condition, to react as early as possible for corrections. And of course, we have to put together the consequences, and we have to balance, you know, how much money we put in condition monitoring and all those things, and how much money we earn from that. Individual service concept. Biofluid and forest machinery. Here in Germany, the use of biofluids is more or less, you have to do it by law. But the owner, of course, say it's expensive, short lifetime of the components, and so on, what you can hear very often. But it's a must, and therefore the focus of the people is only, I have to do it in bio, and that's it. But a smart producer of those fluids, not a very big company, but they have a very nice concept, selling a high-quality saturated ester, superior oxidation stability. And when you now put on it, what is the main influence, what more or less destroys the components and our oil? Contamination in hydraulics and an ester-based fluid water. And they have a very nice oil condition monitoring concept by sensors and oil analysis, use a special in-depth filtration to get the contamination out, particles and water, and don't mix or top up with other fluids to get, as long as possible, a very good condition of the oil. And then the price of the oil is more or less not very important. Special fluids, special concepts. Lubrication in a dry section of a paper machine. Circulating system, rolling bearings, a special approved oil, 10,000 liters approximately. And what they did, applying a clean principle to all lubricants from storage to disposal. They monitor the oil on regular basis by sensors and oil analysis, and they renew 1,000 liters of oil every year. Drain and top up. And clean up the oil permanently by additional in-depth filtration. And the goal? They avoid total oil drains, flushings as best as possible. To minimize downtimes, and because of the downtimes, they bring the money. To prolong the lifetime of the machinery and the oil. They earn money with that. Special machinery, special operation. Let's sum it up. Mr. Einstein stated, all is to be seen relatively, but nothing happens purely randomly. Even Sustainability and good lubrication will not happen randomly. It's a concept in managing lubricated assets. Write down: sustainability wins, reliability increases, and the costs decrease. And if you want to change something, there's only one way: do it. And if you need assistance, ask for it. Ask for the right education course. Ask for people who work and have experience in applying the ICML regulation 55.1 and 2. Thank you for your attention. Thank you very much.
Thank you, Ruediger. It was really a great presentation. Enjoy watching it for the second or third time already. And this morning we had a panel as well, you and me, on sustainability, and you know, there were many good interesting points. I have one comment here from Paul, who says, you know, I like the diagram of the vicious cycle. Oil failures lead to machine failure, which leads to oil failure, which again leads to machine failure. So it's something when you of course dissect the problems, which is quite evident, but too often people don't monitor and don't use the right lubricant to start with. Just one question on that: do you see in Germany, for instance, and in Europe with your customer, that people are more and more conscious about the importance of doing a good condition monitoring?
Yes, you can say it is, but it's not that much we want to have. And therefore we discussed even this morning in the panel, what about oil sensors? And sometimes people ask me, why do you recommend the use of oil sensors? You work for a lab. And the answer is very easy. If something is installed on machinery, giving a red light or something to tell to the operator, hey, the oil is still here and please care for me, this would help us all. This is the first thing. The next thing about this graph, even Paul likes. You know, it is often the discussion, the people see that the oil is black. And now the first word what they use is, yes, the oil is responsible due for this failure. But the oil very often is only the end of this chain, and it has operated under not the best conditions and so on. And therefore, it's not the case. There are things behind, and even this graph should talk about.
Yeah. Thank you. And then there's another question here from William. William says, how do companies in Europe treat recycled oil? What do they do with it? Can you give us some hints or some?
Yes, especially in engines and also maybe gearboxes and so on. Also in hydraulics, we see that we use also recycled oils. It depends, of course, on the quality. But today we have high quality recycled oils, like from Avista or something like that. There you can say that the quality of the recycled oil is better than the mineral oil. Yeah, you have a viscosity index around 110 to 120, you have less sulfur in, and so on. The only problem we see is it depends on the oil price on the market. People accept it. Yeah, that means when the oil price is low, then they love to more or less, they think they have the better lubricant when they buy a new one. Yeah, but it's wrong. And then they say, and if in addition to that, this is cheaper, we choose that. And I think there very often people want to have legal aspects to make it as a must, but I think it's due to the technical things behind not the best way. We should promote the advantages of it, and I think we have in Germany overall a high degree of that. Very often the local government and his what they use and drive, and so there very often the local government says we want to have only recycled oil if possible.
Yeah, and then William is then following up on his question. He asked, are they replenishing the additives back in the oil?
Sometimes I don't know what this now it is related to. When I have now in my mind the paper machinery, when you top up every year a new lubricant, it's the same thing as if you put the additive level to a higher one. That means the only problem is when you replenish additives is there are some legal aspects. They are not that easy to handle, and if you use the same lubricant, there are no legal aspects. You can do it there. If you put this to the recycled oil question, then you must say that Avista produces base oils, more or less, and these base oils now are used to produce new lubricants.
Mm-hmm. Yeah. Good. We have time for one question more, and I see that Eric and Adolfo are kind of building on the same question or topic here, and they are saying the key is to efficiently balance automated analysis with lab analysis. But in the panel that we had this morning, we spoke about that, right? That you always need the lab somehow to do that analysis, but that some data, of course, may come from automated processes or automated sensors.
Yeah, sensors. Most of them produce one or two numbers, more or less. No? Maybe conductivity, maybe cleanliness, maybe water content, what else? Yeah.
Mm-hmm.
And the lab analysis provide maybe 30 or 40 or 50 numbers, the elements, the infrared, the viscosity, and therefore you can paint a picture with much more details. And most of the sensors cannot do that. You have to combine them to more or less to paint a picture which has more the idea of complexity of the oil aging process. Then you can do that, and up to now it is very costly in doing that. And therefore the combination of sensors for the very critical and easy to monitor properties, and then the oil analysis or other inspections to clarify the details, I think this is the right strategy even in the next years.
Yeah, correct. Excellent. Thank you so much for your time, Ruediger, and see you on the platform on the event later on. Thank you so much.
Okay. Thank you.
Bye now. Bye.
Bye-bye.